So in the last part we have discussed about sequential statement rule. In this part we are going to discuss about conditional statement rule. Okay, so how a conditional statement is defined in an algorithm. So if you look at this statement, that statement is if C then A1 else A2 and if. So what does it mean? So if you just explain this one, so what it is telling? It is telling if C is the condition. Okay, so if C condition is true, then A1 statement will be executed. If C statement is not true, then A2 statement will be executed. Okay, so C is a conditional. C is a condition that might be evaluated to either true or false. Okay, so if C is evaluated as true, then A1 will be executed. If C is evaluated as false, then A2 will be executed. Okay, so this is how a branching statement or conditional statement looks like in any algorithm, right? So the conditional statement rule says that for such kind of conditional statement, uh, uh, if the condition C is well defined, meaning that it can be evaluated as true or false, then P and C means with the P condition, if the condition is true, then A1 will be executed and it will lead to the post condition Q. And if precondition is P but the condition evaluated as false, means A2 will be executed. Okay, and it arrives at the post condition Q, then we can tell that P, the algorithm A over arrow Q holds true, means the algorithm is correct. Okay, so what we are trying to do, if we tell it again, if we rephrase it again, so see, there are in branching statement we have one condition, and if the condition is true, then A1 statement will be executed. If the condition is false, then A2 statement will be executed, right? Now going through either of the branch, the algorithm has a purpose, right? So going through either of the branch, the algorithm should arrive at that purpose, right? Algorithm should give the final result, irrespective of which branch it should go. It goes. Okay, so if the precondition holds and the condition of that if statement is true, then A1 will be executed and it should lead us to the post condition Q, right? Otherwise, if P is true, I mean, if along with the P condition, if the condition C is false, which is represented by C bar, then A2 will be executed, right? So, and that also for a correct algorithm will lead to the post condition Q. Okay. So if by both the branch we can we can get into the post condition Q starting from P, then we can tell that the algorithm as a whole is a correct algorithm. Okay, so that is the idea of the conditional statement rule, that we have to verify the correctness for each of the branch. Okay, so for each of the branch we are arriving at the post condition. That is what we have to show. So let us see an example for this. Suppose we want to find out the minimum of two real values, okay, or minimum of two integers or two real values, you can tell. So what will be the algorithm? So in that there will be a conditional statement, right? So how it is? It is telling that if A less than B, right, then the statement A1 will be executed, which is telling M is equals to A. Okay, so if A less than B, M is equals to A, else means if A less than B is false, then A2 will be executed, which is basically M is equals to B, right? So now if we look at this statement, what will be the P conditions? So in this scenario, what we are trying to find out, we are trying to find out the minimum of two real values, right? So the inputs in this algorithm is nothing but A and B, right? We are comparing the value of A and B, right? So A and B are inputs over here. So and that has to be real, some real number, right? Because we are comparing two real values. So the preconditions will be A and B both belongs to the set of real numbers. Okay. Now the question is, what will be the post condition? And if you look at the algorithm, if you look at the statement, what it is doing, it is basically trying to find out the minimum of the two real values, right? So and storing that value in m, right, in the variable m, right? So either in this m or this statement, right? So the post condition will be m is equals to minimum of a and b, right? So whichever is minimum, that should be stored in m. Okay. So so this, with this precondition and post condition, let us see, can we get into the post condition from the precondition, following the conditional statement rule. So what we have to do, so here we'll have two cases, right? One, if the condition a less than b is true, right? So when the case a less than b is true, then a1 will be executed, right? So statement a1 will be executed. In that case, uh, value of m will be assigned by a, right? Assigned by value of a, or value of a will be copied into m, right? So now a1 will be executed when a is less than b, right? It means between a and b, a is the minimum, so minimum will be stored in m. So that is basically nothing but holding the post condition m equals to min of ab, right? Similarly, if the condition a less than b is false, then a2 statement will be executed, right? So if a2 statement is executed, then m will be stored with the value of b, right? So when a2 will be executed when a less than b is false, it means a is either greater than b or a is equals to b. In other sense, that b might be the smaller than a, right? So m is equals to b, uh, which is basically less than equals to a, right? So again, in this case also, m will be assigned with the minimum of a and b. So you can see, via both the branch we are arriving the post condition, which is basically minimum of a and b. Okay, based on the condition. Okay, so so from the precondition we see that, in this example what we see that from the precondition we are arriving into the post condition using both the branch. Okay, based on the cases. So this is how we can prove, or we can formally analyze the correctness of an conditional statement. Okay. So with this we come to an end of the conditional statement rule. In the next part we are going to look into the loop statement rule. Okay.